thought I'd do two examples of proving limits using the epsilon delta definition of some linear function. So I'll do two examples. In this one, we would like to prove that the limit as x approaches 2 of x plus 2 is 4. So what we want to show for this specific example is that for every epsilon greater than 0, there exists a delta greater than 0 such that if we have 0 less than x minus 2 in absolute value less than delta, that just means the distance between x and 2 is close, but they're not equal, and that implies that the distance between x plus 2 and its limit 4 is less than epsilon, so it's going to be close. It's going to be close. So we're going to go ahead and start out with what we want. We want the x plus 2 minus 4 in absolute value to be less than epsilon, and we're going to just work backwards. Okay, I say EQ2 to mean equivalent to, so we're just going to do equivalent steps. Or, I'm sorry, not equivalent steps, but it's going to be equivalent to the previous expression or inequality. So this would be x minus 2 is less than epsilon. So we're trying to get x minus 2 less than something, and then we can work our way backwards. And in this case, we can just go ahead and say delta is epsilon. So for a proof, we're going to let epsilon greater than 0 be given. So we always start off with that. You give us we're given an epsilon, we got to find the delta. Let delta equal epsilon if the distance between x minus 2 is less than delta, then x minus 2 is less than epsilon. And why is that? Well, that's because delta is equal to epsilon. You could put the 0 on the other side. It's not needed though. We don't need that extra bit of information. And that's since delta equals epsilon. And then we'll just do a little trick here. We'll add 2 and subtract 2, and there we have it. We have exactly what we wanted. And then we can just say thus the limit as x approaches 2 of x plus 2 is equal to 4. Okay. The more practice you get at these, the easier they're going to end up getting. Let's do another example, one that's slightly more complicated, not a whole lot more. And we would like to prove that the limit as x approaches 4 of 3x minus 5 is equal to 7. So what we'd like to show is for every epsilon greater than 0 there exists a delta such that the distance between x and 4 is small, implies the distance between 3x minus 5 and its limit is also small. So we're going to start off with what we want. We want the distance between the function 3x minus 5 and its limit 7 to be small. And we're going to work backwards. Okay, so what we want is 3x minus 5 minus 7 to have a small distance. This is equivalent to 3x minus 12 less than epsilon, so we went ahead and dropped the parentheses, combined like terms. We're going to factor 3 out. And we almost got what we want. We want to talk about x minus 4 in absolute value. So we're going to divide both sides by 3. We have x minus 4 is less than epsilon over 3. Sorry, I might have said by 4. I meant to say 3. So we're going to let our delta equal epsilon over 3. And I apologize, it says epsilon over 4. I'm going to fix it in just a second, so it'll be in pink ink for extra emphasis. So delta should be epsilon over 3, not epsilon over 4. So I just wrote it down wrong. So proof, we're going to let epsilon greater than 0 be given. Let delta equal epsilon, and again, it should say epsilon over 3. I'm going to fix this in just a second. If 0 less than x minus 4 less than delta, then 0 less than x minus 4 is less than epsilon over 3, since delta is equal to epsilon over 3. So I went ahead and realized as I was going through, I narrate these after I write them, so I realized I made a mistake. So the delta is epsilon over 3. Okay. Now we're just going to work backwards. We're going to multiply both sides by 3. So 3 times absolute value of x minus 4 is less than epsilon. Put the 3 in. So 3x minus 12 is going to be less than epsilon, and then we'll just cleverly rewrite that as 3x minus 5 minus 7. So that's its function and its limit, less than epsilon. So that's the definition of limit. Thus, the limit as x approaches 4 of 3x minus 5 is equal to 7, and then we can go ahead and say QED. So the linears are not real difficult. This one and the last one are not real difficult. Your delta is just going to be epsilon. If the coefficient, like this one here, the coefficient or your slope is just 1, then delta will be epsilon. If the coefficient is not 1, so here we have a slope of 3x, it's going to be epsilon times the reciprocal. So the reciprocal of 3 would be 1/3, or dividing by 3. When we get into things like quadratics and square roots, then they're more difficult because we have to do some other tricks. So this would be a perfectly good question to ask you. Probably not this exact equation, but not equation, but this exact function. But I could ask you something pretty similar to this.